The James Webb Space Telescope, JWST, has ushered in an extraordinary new chapter in space exploration, offering us a level of insight into distant planets that was once the stuff of science fiction. This remarkable telescope, launched in December 2021, is already revealing secrets about the universe that were previously hidden from us. Its most recent discovery, an artificial light signal from the exoplanet Proxima b, has created a huge buzz in the scientific community and among space enthusiasts worldwide. This discovery is not just a scientific triumph, it has sparked renewed hopes that we may soon find evidence of intelligent life on distant worlds. If this revelation proves true, it would mark the first real evidence of a techno-signature, or a sign of technological activity, from another planet in our galaxy. Proxima b, located just 4.24 light-years from Earth, is the closest exoplanet to our solar system and lies within the habitable zone of its host star, Proxima Centauri. This zone is the region around a star where conditions might be just right for liquid water to exist on a planet's surface. Scientists have long been intrigued by Proxima b because it seems to share some of the qualities that make Earth such a unique and life-friendly world. However, until now, we had no direct evidence of whether it harbors life. The ability to detect artificial light on Proxima b, using JWST's advanced infrared instruments, is an enormous step toward answering that question. JWST's mid-infrared instrument, MIRI, is the star of this new era of space exploration. MIRI is extremely sensitive to infrared radiation, which is essentially heat emitted by objects, including planets and stars. This makes it the perfect tool for detecting distant artificial light sources, such as city lights, industrial facilities, and even potentially alien technologies. The JWST is so powerful that it can detect faint infrared emissions across the vast distances that separate us from other stars. When scientists pointed JWST at Proxima b and observed its infrared signature, they found something extraordinary, evidence of artificial light. This is the first time that we've observed what could be an actual techno-signature, suggesting that there may be intelligent, technologically advanced life on Proxima b. This discovery is particularly exciting because it could open up a whole new way of searching for extraterrestrial life. Instead of focusing solely on signs of life such as water or atmospheric gases, we could begin to look for evidence of civilizations that might be using energy sources that emit artificial light. In a universe as vast as ours, with billions of stars and even more planets, the possibility that we are not alone is becoming ever more likely. While this discovery on Proxima b is the first of its kind, it is just the beginning. The JWST's ability to detect artificial light is a breakthrough, but the potential applications of this technology extend far beyond Proxima b. It is now possible to study other planets throughout the known universe for signs of technology, even if those planets are far beyond the reach of our current spacecraft. The MIRI instrument on JWST works by detecting the heat signatures of objects, which can include natural emissions like the light from stars or the heat from a planet's surface, but also artificial sources, such as the glow of lights in large cities or industrial zones. What makes MIRI so valuable in the search for extraterrestrial life is that it is capable of detecting these artificial light emissions at incredible distances. In the case of Proxima b, the artificial light detected could indicate the presence of large-scale urban areas or technological infrastructure, things that would suggest the presence of advanced life forms. While scientists are still investigating the exact nature of these emissions, the discovery opens up a whole new way of looking at the universe. This is a game-changer for the search for life beyond Earth. For decades, astronomers have been scanning the skies, looking for planets in the habitable zone, where conditions might allow liquid water to exist. Proxima b, as the closest potentially habitable planet, has long been a target of interest. However, finding a planet in the habitable zone doesn't necessarily mean it's home to life. Many other factors, such as the planet's atmosphere and its ability to retain heat, also play a role in whether it can support life. Now, with the ability to detect artificial light, scientists have a whole new dimension to explore when studying distant worlds. The discovery of artificial light on Proxima b is particularly significant because it suggests that we may not have to rely solely on searching for signs of biological life, such as oxygen or methane, which are often considered biosignatures. While these gases are indicators of life as we know it, they don't necessarily point to intelligent life or advanced technology. Artificial light, on the other hand, is a clear sign of a civilization capable of harnessing energy and using it to power complex systems. It's the kind of signature that would be much harder to miss. In addition to the MIRI instrument, the JWST is equipped with a suite of other tools that allow scientists to study the atmospheres of exoplanets in detail. These tools can help researchers determine the chemical composition of a planet's atmosphere, which is a critical part of understanding whether a planet can support life. For example, the presence of water vapor, carbon dioxide, and methane in a planet's atmosphere could indicate that the planet is habitable, while the detection of ozone could be a sign of biological activity, as ozone is produced by life forms on Earth. The JWST is already beginning to provide this kind of data for planets like Proxima b, and as we continue to analyze these observations, we may learn much more about the potential for life on other worlds. But the JWST is not the only telescope that will play a role in this exciting new phase of space exploration. In 2028, the Extremely Large Telescope, ELT, will be launched in Chile, and it promises to take our understanding of distant planets to a whole new level. With its 39-meter main mirror, the ELT will be able to capture much sharper images of distant objects than any telescope before it. This next-generation telescope will be capable of studying the atmospheres and surface properties of exoplanets with unprecedented precision. Like the JWST, the ELT will be able to detect faint signals from distant planets, but with its larger aperture and advanced technology, it will be able to see even further and with more clarity. The ELT is expected to be able to observe exoplanets in more detail than ever before. It will be able to detect traces of water, carbon dioxide, methane, and other biomarkers in the atmospheres of exoplanets, as well as study the light reflected from their surfaces. This means that, in addition to detecting artificial light, the ELT will be able to search for signs of biological life and study the potential habitability of distant worlds in greater detail. One of the most exciting possibilities is that the ELT could be used to study the surface of Proxima b, providing even more information about its potential to harbor life. The ELT is just one of many new telescopes that will help us study exoplanets in the coming years. Another telescope, the LUVOIR, Large Ultraviolet Optical Infrared Surveyor, is currently in development and will focus on studying the atmospheres of exoplanets with even greater precision. LUVOIR's advanced sensors will allow it to isolate and analyze the light from distant exoplanets in ways that were previously impossible. This could open up new opportunities for detecting biosignatures, including the telltale signs of plant growth, such as the vegetation red edge, VRE. VRE is a spectral signature created by the reflective properties of chlorophyll, the pigment found in plants on Earth. If LUVOIR is able to detect this signature on distant planets, it would be a major step forward in our search for life. While we have made incredible strides in our ability to study distant planets, there are still many challenges to overcome. One of the biggest hurdles is the sheer distance between Earth and the exoplanets we want to study. Even with the most powerful telescopes, it still takes years or even decades to send and receive signals from these distant worlds. For example, Proxima b is more than 4 light-years away, meaning it would take more than 4 years for a message to travel there, and another 4 years for a response to come back. This time delay makes it impossible to communicate with extraterrestrial civilizations in real time. However, there is hope that advances in quantum technology could one day solve this problem. Quantum communication, which uses the principles of quantum mechanics to transmit information, has the potential to revolutionize the way we communicate over long distances. If quantum computers can be developed to the point where they can process and transmit information instantaneously, we could one day communicate with civilizations on distant planets as if they were right next door. While this technology is still in its infancy, the progress being made is exciting, and it could one day allow us to send messages to planets like Proxima b and receive replies in real time. In the meantime, astronomers will continue to use tools like the JWST, the ELT, and other future telescopes to search for signs of life in the universe. the discovery of artificial light on Proxima b is just the beginning of what promises to be an exciting new era in space exploration. With each new discovery, we move closer to understanding whether we are truly alone in the universe. As technology continues to improve, the possibilities for what we can learn about distant worlds are virtually limitless. Who knows what other incredible discoveries are waiting to be made? As we look to the stars, the answers to some of humanity's greatest questions may be closer than we think.